This video provides an overview of the Aparian PA-Link product providing EtherNetIP and Modbus TCP connectivity to PROFIBUS PA. In this presentation, we will cover an introduction to the product, typical architectures, its configuration, and also describe the available diagnostics. The PA-Link simplifies a PROFIBUS PA installation by incorporating many of the ancillary components required in traditional systems. Firstly, the module is a PA master and thus no DP master or DP to PA coupler is required. The PA-Link also includes an isolated power conditioner supplying power to the bus, which can be disabled by software. An internal software-controlled bus terminator is also included. The power conditioner has a software configurable current trip limit, providing protection from bus faults. The PA-Link provides tight integration with Logix and automatically creates user-defined structures for each PROFIBUS PA device. Now let's look at some of the PA-Link's key features. As mentioned in the previous slide, the module provides a direct link between PROFIBUS PA and either EtherNetIP or Modbus TCP. It has the ability to exchange up to a total of 2 kilobytes of PROFIBUS PA data and status information from up to 32 PA devices. The embedded switch provides 2 Ethernet ports which can be configured for a device level ring, providing Ethernet media redundancy. The onboard isolated power conditioner can source up to 420 mA. The onboard bus terminator and power conditioner are both enabled via software. The PA-Link can operate as a standalone master or in a redundant master configuration. In a redundant configuration, the standby module will automatically take over from the previously active master in the event of a power failure or Ethernet connection failure. The changeover is bumpless and the PA's device operation is uninterrupted. The PA-Link supports asset management through the use of FTT-DTM technology. We will now look at some typical network architectures as well as the required wiring of the PA-Link module. In the first example, we see the PA-Link connected to a Control-Logix controller via EtherNetIP. The PA-Link and the PA devices are connected directly to the trunk. The onboard power conditioner and bus terminator are both enabled. This example is identical to the previous, except the bus is making use of third-party segment protectors. These devices typically limit the current to the PA drop and thus protect the remainder of the PA bus from an accidental short circuit on one device. Here is the same architecture, except the PA-Link is connected to a Modbus TCP device. The PA-Link can be configured as client or server when using Modbus TCP. Intrinsic safe applications can be supported with the use of an external third-party IS barrier and power conditioner combination. Depending on the type of barrier or repeater used, the onboard power conditioner may need to be disabled. In a redundant master configuration, both PA-Link's onboard power conditioners are enabled. Under normal conditions, the power consumed by the PA devices is derived from both PA-Link modules, effectively sharing the load. If the power to one of the PA-Link modules is removed, then the other PA-Link would supply all the required bus power. Only one of the PA-Link modules would be active at a time, and the switchover between them is seamless. Wiring the PA-Link module is relatively simple. The DC power is connected to the back connector, and the PA bus is wired to the front connector as indicated in the diagram. Note that the maximum current supplied by the power conditioner must be derated for temperatures above 50 degrees Celsius to a maximum of 70 degrees Celsius. We will now look at configuration. As with all Aparian modules, the PA-Link is configured using the Aparian Slate configuration software, which can be downloaded free of charge from the Aparian website. The first step is to register the required GSD files using the GSD file manager. These files are provided by the PA device manufacturer. Once you have added a PA-Link module to the Slate project, you can configure the PA master. Firstly, configure the mode, redundant or standalone, and the primary interface, EtherNetIP or Modbus TCP. Next, set the physical parameters, setting the power conditioner and bus terminator enables, and bus current trip limits. There are a number of PROFIBUS timing parameters that can be configured, but the software will automatically calculate recommended values. Where required, the advanced settings, including NTP and device level ring, can be configured. Where Modbus has been selected as the primary interface, a number of addressing and mapping options are available to suit each application. A maximum of 32 PA devices can be added to each PA-Link. These can either be added manually offline by selecting from the GSD file manager, or alternatively, when online with the devices connected, making use of the device discovery function. The slot configuration is automatically populated using the defaults from the GSD file. The user can then modify this configuration within the constraints of that file. Note that the description of fields are used as the member names in the generated UDT for import into Logix. When using the PA link with Logix, the next step is to add the PA link to the Studio 5000 IO tree. This makes use of the EDS add-on profile. Slate generates a Logix mapping routine L5X file, which includes all the required user-defined data types and tags. This allows the tag structure in Logix to reflect the specific data structures of each PA device in the project. Diagnostics. The PA link provides a wealth of diagnostics information to assist in the efficient and successful commissioning of a PROFIBUS PA system. This information is not only available in the Slate software, but is also packaged in the Logix tag structures or Modbus registers. Diagnostics pertaining to the master include bus voltage and current, live list, and global communication statistics. For each PA device, the status and individual communication statistics are also provided. The PA link features a powerful PROFIBUS packet capture function at no additional cost. PROFIBUS PA packets can easily be filtered and their content decoded and displayed. Capture files can be saved and emailed to facilitate remote support. And finally, the PA link supports FTT-DTM technology, providing vendor-independent asset management capabilities. PA devices can be remotely configured and monitored using graphical device type managers or DTMs provided by their manufacturers. This technology further simplifies device replacement, particularly for complex PA instrumentation. This concludes the product overview of the Aparian PA link module. For more information, please visit aparian.com or email sales@aparian.com.